Hi, I want to show you how you can use your graphing calculator to help you solve equations and inequalities. To solve equations graphically, you're going to learn how to find the intersection, and you're also going to learn how to find the zero. To solve inequalities graphically, we're really going to use these two methods combined with being able to read the graph correctly, and there is a third method that I will show you how to do. So to use the intersection of graphs, what we're going to do is find the intersection point. And when we say to find the intersection point, if we have this equation of the form y1 is equal to y2, we're going to try to find the x value where the graphs intersect, and more specifically, where the graphs of y1 and y2 intersect. And that x value is the solution of the equation. So to do that, we're going to first enter the left side of the equation into y1, the right side into y2, graph, and then use our trace commands and actually do second trace in number 5, which is the intersect feature. And then we're going to have to answer a series of questions that is posed on the calculator screen. So I have already typed some into a calculator, and I have the screenshot saved for you here. And so let me just talk through what you would do on your own calculator. So as an example, if we would want to solve 9x minus 17 equals 2x plus 4, I know you could all do that by hand. To do it on the calculator, you're going to let one side be y1 and the other side be y2. And then enter by pressing your y equals key. Enter the left side expression into y1 and the right expression into y2, and then graph. And this is graphed in the standard window, but you can see that the point of intersection is almost off the screen. So I adjusted the window. Go to your window command, and I simply enlarged my window in the y direction. I changed my y max to 20 and my y scale to 2. And now when I graphed it, I see a better picture of how those two graphs relate to one another. So after you change the window, go back to view the graph. Now what you want to do is find this point of intersection. To find that point of intersection, I'm going to go to second trace and choose number 5. And then it asks you first curve. And you notice how when it says first curve, this is automatically done for you. If y1 is 9x minus 17 and y2 is your 2x plus 4, you really don't have to even think about these. This is more important when you have more than 2 equations entered into the calculator. And then you would have to use the up and down arrows to scroll through the different equations that are graphed. But your first curve is 9x minus 17. It automatically starts by going to the y-intercept point. So you may not even see it on the screen, but it is there. So once you see first curve, you're just going to press enter if indeed that is the equation that you want to include in the solution set. And then it asks you second curve, and you see how it toggled to the other graph. And then you would press enter. Again, you notice how my expression changed. And you may have to change that on the calculator. If you don't see the expression for the equation on your calculator, you can go to second and zoom. If you do second and zoom and go all the way down to the last row, which is expressions on, and make sure that's highlighted and press enter, and that way when you go to the graph window you'll see which equation is actually showing. So you do first curve, enter, second curve, notice how it changed my equation, and I press enter, and then it asks you for a guess. So this time you want to use your left or right arrow keys to move close to the point of intersection. Don't move your up and down arrow keys because that will take you off the graph. But you want to use your left and right arrow keys to move. And since my second guess was, or second curve was over here, I had to use the right key, right arrow key to move to the point of intersection. And it doesn't matter what that value is. Just press enter once you move to the point of intersection. And you know what? You really don't even have to move. Unless you have more than one point of intersection, the calculator needs to know which one to approximate. But if you only have one point of intersection, you could just simply press enter when it asks you for a guess. And then you notice that it displays the intersection point down at the bottom. So that intersection point then is the solution of that equation. Now, let's go through the method of finding the zero to solve the equation. So this is our method 2. And to find the zero to solve the equation, you're going to have to understand that if the equation is of the form y1 equals y2, to find the zero, we're really trying to find the zero of y1 minus y2 is equal to 0. Because the zero is the value of x that makes an expression equal to 0. So we have to rewrite the equation so that we get 0 on one side. And then we're going to enter that difference of those two equations, or two functions rather, into the calculator and use our second trace, and number 2 is for 0. Then we have to enter a few bounds and guess. So let me show you how that works out. So if we want to solve using the zero function for the same problem, the only difference is I can't enter a y1 and a y2. I can only enter one expression. And so I have to enter it so that I have one side equal to 0, which means I've got to subtract that entire expression from both sides. So you'll notice in y1 here I entered 9x minus 17 minus, in parentheses, 2x plus 4. Now you could certainly go ahead and distribute to get minus 2x minus 4 if you wanted to. That would be fine. And now I graph. So you see I only have one function. The solution is the 0, or the x-intercept. So I've got to calculate that value. To do that, I press second trace and I choose number 2. And whenever I do that, I'm asked to enter a left bound and a right bound and a guess. The left bound is a point to the left of the 0. So I had to go here, that is in the fourth quadrant somewhere, where I notice that I have a positive and a negative x and y value. Didn't really what those are, but sometimes you can't see the cursor. It's off the screen, so you need to make sure you're looking for the correct signs for those points that are denoted here. So you choose a left bound somewhere to the left of, in fact, if you could draw an imaginary line, let me try to do it in a different color. If you could draw an imaginary line down through the 0, the left bound is somewhere on the left side of that line. And once you choose that, then you would press enter. Then it asks you for a right bound. Oh, and also let me tell you this, when you press enter, do you notice how it marks with a little arrow symbol where you mark that? Now the right bound is to the right of that 0, so you need your cursor then on the right side of that 0, and then press enter. And notice how it marks. And then your guess needs to lie somewhere between those two marks, so you may have to move your cursor a little bit, and then press enter after you move your cursor between those two markings. And notice that it tells you what the 0 is. And that's the same value that we found for the x value, the point of intersection. Okay. Now to solve inequalities on the calculator, the x-intercept method, which your book sometimes refers to instead of the 0 method, but it's really the same thing. Intersection of graphs, there's nothing new here. It's just changing in how you answer the problem and what you're looking at on the graph. Because with inequalities, you're looking for regions of values of x that satisfy that condition. So those two methods are the same as we've talked about before. You're just going to add on how you apply those to the problem in a different way. There's another way you can solve inequalities on the calculator, and the way you do that is you simply enter the entire inequality into the equation editor. So for instance, if I wanted to solve 6 minus 3 times 1 minus x is greater than 9, what I could do is enter that entire expression into y1. Now I did want to point out here, the way that you get that inequality symbol to display is you have to press second and math, because what you want to get to is the test menu. And then you would just select the appropriate symbol. So here I needed greater than, so I selected number 3. Okay. And then graph. So notice that this one is graphing not the line, it is graphing the region that we should be shading on our number line. So it's saying everything to the right of 2 should be shaded. This is not a very good method to help you know with fractional values. You don't really know that endpoint precisely, so you have to do some work to find that. But the other thing is you also don't know from here if you have to do a parentheses or a bracket. But you can go to the table. If you press second and graph, zeros mean that those values of x are not in the solution set. Ones mean the value are in the solution set, so they are included. But here, it's hard to know between 2 and 3 what's going on, but actually between 2 and 3 are infinitely many numbers that are also solutions. So my solution set would say not to include 2, but on to the right to infinity. Now, if you did this by hand, you could actually find that out, right? If you did 6 minus 3 plus 3x is greater than 9, you get 3 plus 3x is greater than 9, so 3x is greater than 6, so x is greater than 2, which confirms the graph that we've seen here. So this really may help you more with deciding which side of the reference number you need to shade and so on. Okay, so this concludes how you can use your calculator to solve equations and inequalities. Contact me if you have questions. Thank you.